Last time we talked about how to graph a line when they give us the equation. So I want to just go and do a couple more examples of that. That's what your homework was on. Thank you, sir. And then we will dive into today's material. So just a reminder, headphones out, earbuds out, phones off and away so that whatever the weird sounds are happening from our phone doesn't keep happening. And so just a reminder from last time, so let's say we had y equals negative 2/3 x minus 4. So this is in what we call slope-intercept form. And slope-intercept form tells us our slope and our y-intercept. So my slope-intercept form is y equals mx plus e. This is my y-intercept. And n, the number in front of your x, is your slope. Okay, so for this particular one, here's my y-intercept. So I go down 1, 2, 3, 4, plot that point. And then this is my slope. So the top number tells you how much you go up or down. The bottom number tells you how much you go left or right. Since it's a negative 2, I'm going to go down 2 and then positive 3 to the right 1, 2, 3. So keep repeating. Down 2 to the right 1, 2, 3. And from that point that I just did, down 2 to the right 1, 2, 3. Now, anytime that you have that negative slope, you can think of it as negative 2/3 or 2 over negative 3. So you could go the other way. You could go up 2 and to left 1, 2, 3. So you could just do the opposite, whichever you prefer, whichever you have room for. Okay, just connect your dots. Make sure you don't forget to put arrows on the end to indicate it's going on for forever. And let me just want to do one more example. Let's say we have y equals 5x plus 2. So here my y-intercept is 2, positive 2, so I just go 1, 2, plot my dot. And then my slope is 5. Well, we want it to be written as a fraction, so slope, which we represent with an n, same thing as saying 5 over 1. So I would go up 1, 2, 3, 4, 5 over 1. And again, I can do the opposite. Down 1, 2, 3, 4, 5 to the left 1. Down 1, 2, 3, 4, 5 to the left 1. Remember, in the end, a positive slope, where it's a line of positive slope, should look similar to my red one, where you're climbing up. It's like you're walking up the stairs. The slope that's negative gives us a line going down. It's like going down the stairs. Okay, so that's what we did last class. Do we have any questions with that? Because what we're doing today is builds upon this. So you have to know how to graph a line before you can do what we're doing today. Okay, so what we have today, if you take a look at your stamp sheet, you'll notice we don't have a mini quiz today. We're on day 5. We don't have a mini quiz today. Our mini quiz will be next class over graphing the line and what we're doing today. Today we're learning how to do transformations. And so we actually have a foldable for this, which means we get to fold some paper. Woo! So I'm going to pass out this paper and give you some instructions. That's kind of how it goes. For those of you that came in late, if you have your homework, you can get that out so I can check it. I'm going to put your guys' in this row so you don't have to walk. So we're going to just hand those to Alice. Thank you. Did you just pass yours away? Yeah. Those are for you, Andrew. You're usually passing them. Oh, sorry. I'm sorry, man. Me? Andrew got me when I told you to pass Alice off and you haven't passed it to Alice off. And Alice off because I know it's just for you. Saw you 20 minutes ago. 25 minutes ago. So you'll go to your TA, report in there. Which is on the first floor. Does that make sense? That's kind of confusing to me. Wait, so you'll go to your TA, which is in this room. You'll check in there with them. And then at 9:85, you'll go to I don't know why, actually. Here we go.
And if you showed up and she would just say,
Okay, everyone should now have a white paper, a blue paper, and a green paper. And on each of these, you'll see a dotted line. I want you to go ahead and fold on the dotted line for each of these. I'll eventually tell you which direction and how to assemble it, but just going to start off by folding on the dotted line for each of them. So I'm going to give you a little bit of a chance to try to figure it out on your own, but we should have it in this order when it's all folded and put together. See if you can get that figured out. Have it in this order. It's all folded and put together. See if I can get it a little I'm going to take attendance while you guys are doing that, which is going to take a while. Yes, I will pass around staplers once everyone gets it all ready, and I'm done taking attendance for O'Reilly people. Once you've gotten yours in this proper order, look around and help those that are nearby you. You might have to fold it the opposite direction.
Like this one. You got the other one.
Hold on, I'm going to finish taking attendance first. Okay. I thought, can I borrow your photo book for demonstration? Thank you. Okay, so you should have blue linear transformations on top. Then next comes the white parent function. Then comes green reflection over the x-axis. Green again, vertical shift translation. Then white, steeper, flatter dilation, and blue application. I'm going to go ahead and pass around staplers so you guys can staple at the top. It's just like our one from last unit where we're going to be flipping up. So think about that as you're stapling. You'll make sure you allow enough room for it to open and take notes inside. If you're struggling with folding or getting in the right order, just raise your hand. I'll come help make sure that you've got it in the right order. Alright, so everyone else that needs me to double check that they've got their foldable folder correctly. And then Marjorie and Pachi, when you're done with your bins, you can just turn them in there to the bins. Yeah, I'll sort there. You can just throw it all in there. Okay, so we'll go ahead and start with our notes while the staplers are being passed around. So this is something that they added into Algebra 1 last year, and this is what we call transformations. This is something that you'll continue to learn in Algebra 2. We in Algebra 1 only do linear transformations, which means we're doing this only with the line y equals mx plus b, which is a line. That's why you see linear line is in there. So we're going to be basically taking this line and shifting it all around the graph. So we look at the different types of transformations that we have today. So go ahead and open up that first flat. So our first thing we want to talk about is a parent function. The parent function is our starting point. It's like the original function. It's the most basic of all functions in the family. When we take this function, we call it a family of functions, all the possible ways we can move it. So the parent function is like your starting point. All right. So the most basic of all functions in the family is the parent function. The parent function. For linear equations, parent function is y equals x. So this is like our most basic beginning parent function. All linear functions are transformations of this parent function. So once we start moving it all around, it's called a transformation. It's moving it in somewhere, it's transforming it somewhere. So again, linear equations, let's talk about y equals mx plus b. My parent function, that's my starting point. My original function is y equals x. So we're going to go ahead and graph that parent function, y equals x, on our graph over. Now that parent function, y equals x, what is my y-intercept of y equals x? 0. Yeah, there's nothing added onto the end. So my y-intercept is 0. So when I go to graph it, I start off by putting a dot at 0, 0. Now what is my slope of y equals x? 1. Good. There's not a number in front, so 1 is the number in front. And that is my slope. Remember, slope, if I have 1, that's the same thing as 1 over 1. So I go up 1 to the right 1. Put my dot. Up 1 to the right 1. And we can keep doing this all the way up. And do opposite all the way down. Alright, so just going to connect your dots. Make sure again you put arrows on this. So this is our parent function, y equals x. This is our starting point. So what we do with transformations is they'll ask you to do transformations, sometimes in words, sometimes they ask you to describe the transformation. So we might shift this whole thing. You don't have to actually draw this, but I can take this whole line and I can shift it left or right. I could shift it up or down. And I could even reflect it. Thank you, sir. I could even reflect it across a line, which means it's going to flip around. I don't know if I can get it to flip on here. Flip. Let's see if it does. There you go. So you can even have it flip. These are different types of transformations that we have. Okay, so again, this is our starting point from all other graphs for doing this. So when we were graphing for our homework, we were actually doing transformations of this. Okay, let's go and look up the next flat. And we have reflection over the x-axis. So reflection over the x-axis, I think this one's probably the harder of the transformations, but when we have lines, it's actually not that difficult. It's when we get into our equations in Algebra 2 that's a bit more work. So with our reflection, what this does is it basically just takes the line and flips it So it says across the x-axis. Here's my x-axis. So it takes your line and flips it across it. So anything that's above gets flipped upside down, anything down below gets flipped up above. It's almost like there's a mirror here and it gets flipped across. Alright, when our slope is negative, our line reflects, or you might say flips, over the x-axis. And again, this is our x-axis. So here's my x-axis, here's my x-axis. So let's start off by looking at Q positive y equals 3x. Now you'll see there's already a dotted line drawn in here. This is just our parent function. And we just have that drawn in lightly so you can kind of see how it compares to our parent function. So let's go ahead and graph this. Y equals 3x. What is my y-intercept for this one?
0.
Good. My y-intercept is 0. And what is my slope? 3. Good. 3, which is the same thing as 3 over 1. So again, I start off at 0. And now I go up 3 to the right 1. Up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. Then we can just do the opposite on the other way. Down 1, 2, 3 to the left 1. Down 1, 2, 3 to the left 1. Down 1, 2, 3. Okay. So here's our positive slope. But then when we have the exact same equation, except the slope is negative, what it does is it's going to take this piece here, and that gets flipped upside down. And then it takes this piece here, and that gets flipped right side up. So that's what we're going to be doing. Let's go and take a look at how. So we should end up with something that looked like that green line I had there. So again, let's go and identify our y-intercept and our slope. What is our y-intercept for this one? Good, it's still 0. Let's go and plot that dot. And then my slope, negative 3 or negative 3 over 1. So what I'm doing here is I go down 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. And again, I can do the opposite. Up 1, 2, 3 to the left 1. Up 1, 2, 3 to the left 1. Up 1, 2, 3 to the left 1. For me as I stand in front so I can graph it a little better. So again, we see that what happened is this piece here got flipped upside down. See that over here. And then this got flipped upside, which we stood over there. Now what's nice with lines is that you don't have to worry about taking each point and flipping it across that x-axis. As long as you just do your slope, it'll take care of it for you. But what we call this is a reflection. Okay, it's a reflection over the x-axis. So when you see that negative slope, that means there's that reflection over the x-axis. That's the vocabulary that the SL likes to use. So I'm going to go and just highlight that. Reflection. And we're doing it over the x-axis. So we have questions with that. Again, as long as you just do your slope, it'll take care of itself. When you get to Algebra 2, they're going to give you some crazy functions where you have to actually take individual points and like move them across the x-axis. But for us, I'm just graphing. Okay. So as you can see, today we're just doing more with graphing, just through the lens of transformations. Okay, next let's go and do vertical shift. A vertical shift we call a translation. So it translates for vertical up or down. Okay, so again, in each of these examples here, and it's very lightly drawn dotted, that's our original parent function. So we can see how it relates to it. But we're going to go ahead and graph these functions here. All right, let's do this first one. What's my y-intercept for this first one? Let's do positive 2. And what is my slope for this? Good, left, just 1 over 1. So I go ahead and I put my y-intercept at 2. Again, go up 1 over 1, up 1 over 1, up 1 over 1, 1 over 1. And keep doing this. I got a little wonky there for a while. Down 1 over 1, and over 1. It starts to get harder when the smartboard's not exact. I'm just going to get a little better up here. Go ahead and use that as a reminder to make sure our phones are off and away. Earbuds out of our ears. Alright. I think that's enough points to go ahead and connect to my line. And again, make sure you have arrows on either side. Alright. Let's go and take a look at this one. What is my y-intercept for this guy? Ooh, this one having a -3. Good. Here's my y-intercept. My y-intercept is -3. Now, what's my slope for this? Still 1 over 1. So I got my y-intercept 1, 2, 3. It's at -3. And then again, slope is 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1. Up 1. Up 1. Alright, that seems like enough for a line. Okay. And then our last one down here. What is my y-intercept for this guy? Good. +5. Sam, put it away, please. What is my slope for this one? 1. Is that number right in front? So 1 or 1 over 1. So I put my y-intercept at 5. And again, up 1 over 1. Keep doing that. Seems like enough points. Up 1 over 1. And again, I'm going to make sure you don't forget your arrows. Okay, so let's talk about in words what has happened here. I'm comparing this to my original parent function. Whoa, whoa, whoa. Okay, I'm comparing this to my original function. So if this is my original function, if I were to take this, what am I doing to get it to match those points for my new graph? Yeah, I'm moving it up. And then specifically, I'm moving it up 2. Right? If I take a look, let's see, let me see if I can zoom in a little more here so you guys can see it a little better. So if I'm taking this point right here where my cursor is, I go up 2, if it lets me, and there's my new graph. Notice my y-intercept was +2, so I have my original parent graph. Here's the original parent graph, and then what did we do? We added 2 to it. So we went up 2. Let's check out over here. Again, my original parent graph. If I take that there in the middle, I can go down 3, and that's my equation there. So again, if I look at my equation, I have the original parent graph, and then what did I do? I subtracted 3, so that's down 3. And same thing over here. Here's my original parent graph, and then what did I do? Added 5. So I went up 5. And we again can see that. If we start here and go up 1, 2, 3, 4, 5, boom, there it is. So whenever we have that change in the y-intercept, changing the y-intercept, or also changing the constant, right? If we have y equals mx plus b, my constant is this b, which is the y-intercept. So changing the y-intercept creates a vertical shift. Vertical means it moves it up or it moves it down. And again, when we move it up or down, that's simply taking our y-intercept value and moving it up or down, however much that is. So as long as you graph it just like we normally do, you're going to take care of that. So change the y-intercept moves it up or down, and we call this a vertical shift. So again, something that the SWL will ask you, and thus our test will ask you, is to describe the transformation from our current graph. I can look at this, I see +2, so it shifted up 2. That's all I have to say, shift up 2. Alright, questions with our vertical shift. Again, right now, all we're doing is just what we did last class, we're graphing it, but now we're talking about what that means in terms of our transformation. So we have shifting up or down, we just look at our y-intercept. We have reflecting across the x-axis, that's if our slope is negative. Okay, so next we have talking about whether it's steeper or flatter. This is called a dilation. Okay? And this comes back to our slope. So let's go ahead and graph each of these. So my smartboard's losing it. Let's see how well it does here. Okay. So it says to graph this equation. So once again, let's go and identify what is my y-intercept for this? 0. There's nothing added onto the end. Go ahead and put it at 0, 0. And then my slope here is 2 or 2 over 1. Again, this number just in front of x. So that means I go up 1, 2 over 1. And I'm going to take this from my computer since the smartboard is not cooperating once again. Alright, so I go up 1, 2 over 1. Up 1, 2 over 1. And you go ahead and do the same on your paper. We do the opposite, down 2 over 1, down 2 over 1. So 1, 2. Alright, I think that's enough for a line. Go ahead and connect those dots for a line. Alright. So again, we have it goes through the point 0, 0, then up 2 over 1, up 2 over 1. Okay. So this was a positive 2 here. And if you think back to original parent graph, remember our parent graph is y equals x. What is my slope of the parent graph? What's my slope of y equals x? 1. So 1 in front, my slope is just 1. Is 2 bigger or smaller than 1? Is 2 bigger or smaller? You've got the right idea, just flip-flop. Okay. 2 is bigger than 1. Notice it got steeper. It went up faster, right? It got more steep. This is going to be a harder set of stairs to climb than our original parent graph. Okay, let's take a look at our next one down below it. What is my y-intercept for this one?
0.
Good, y-intercept is 0. And what is my slope for this one? 1/2. Okay, so before we graph, I'm going to ask you, compared to my parent function is a slope of 1. Here I have a slope of 1/2. Is that bigger or smaller than my original? It's smaller. Okay, so let's take a look at what that looks like. Okay, I'm going to do this from my computer because I don't trust the smartboard. So let's go ahead and graph it. We have our y-intercept is at 0. And my slope is up 1 over 2. Up 1 over 2. Up 1 over 2. Again, we can go opposite, down 1 over 2. Down 1 over 2, down 1 over 2. Okay, go and connect your dots. We'll do it up here as well. All right. So above we had my slope was bigger, it got more steep. Here my slope is smaller. Compare that to our parent graph. Compared to my parent graph, it's less steep or flatter, right? It doesn't go up as fast. So when we had it was bigger, it was more steep, harder to walk up that hill. When it was smaller, it was less steep. It's going to be easier to walk up that incline. Think about running up that hill. That would not be fun. Alright, let's go and take a look at this one. So again, here we have a larger slope, so it's going right out this. We have my y-intercept is still 0, and here my slope is 3, or 3 over 1. Write that number right in front of us. Down here, my y-intercept is 0, and my slope is 1/3, right in front of us. So let's graph each of these, and we should expect that our larger slope is going to be more steep, and my smaller slope, because it's less than 1, is going to be less steep. So let's check and see. And we're just graphing like we did last class, so we're not doing anything new in terms of how to graph it. We're just talking about it in different terms. So up 3 over 1, up 3 over 1, up 3 over 1. Down 3 over 1, down 3 over 1, down 3 over 1. And go and connect your dots. Alright, and again we can see it's more steep. It's going to be steeper to climb up this ladder than to climb up our parent function ladder. And let's go and check down here. So it's 0, 0. And up 1 over 3, up 1 over 3, up 1 over 3, and we can do the opposite. Down 1 over 3, down 1 over 3, down 1 to left 3. And again, let's do our line. Okay, and again, this one's going to be less steep than my original parent graph. My new graph, it's less steep, it's flatter. You don't have to climb up this high. So this, again, tells us about a dilation. Okay? So what we have is the bigger our slope, the steeper our line. As we saw here, even looking from red to blue, blue got even steeper. Let's say we went even more, like a slope of 5, even more steep. Slope of 10, even more steep. So the bigger our slope, the steeper our line. And so it goes up faster. The smaller our slope, our line becomes less steep. Or you might say flat, right? It's more likely to be kind of flatter. Okay. So the bigger our slope, the steeper our line. Think about it if it was a ladder. Climbing up that ladder, it's going to be more difficult for the larger line. For the larger slope. And then when it's a smaller slope, it's less steep, a little flatter. That's easier to climb up. Alright, we call this a dilation. Now, I believe the SOL likes to focus on using the words steeper and flatter, or steeper and less steep. So they typically like to ask you questions such as, they give you this line y equals 1/2 x and say, how does this compare to our original parent graph, or what is the transformation? And we can say it is less steep. So really just compare and look at the graphs. Okay. So that is our steeper / flatter dilation. Do we have any questions? So then last, we're going to kind of just put it all together in words here. So again, this is one of the newer topics on the SOL. So this is similar to the type of stuff they're going to ask you about. You can see it's kind of the SOL format here where they give you directions, you have to circle and choose and whatnot. So here it says select the correct answer. I'm going to zoom in a little more so you can see it a bit better. Okay, so it says let f of x equal x. Remember, that's just y equals x. And g of x equal 1/2 x plus 4. So y equals 1/2 x plus 4. Complete the statements to compare the graph of g of x to the graph of f of x. So I just want us to describe what has happened between it. Remember, this is my parent function here. It's my original. So we're going to describe what is different from here to this guy. Now, we can, of course, use our calculators and graph it to see, but we can also just take a look at our information. I see that I have y equals x, and then now I have what's different here. My 1/2 is different, and my plus 4. Again, a y-intercept on the end, or adding or subtracting number on the end, shifts it up or down. Changing my slope makes it either more steep or less steep. So they go ahead and have a fill in the blank here. The graph g of x, so talking about this one here, is shifted. So shifting, we have it shifts up 4. So it shifts up 4 from the graph of f of x. Oh, circle the answer that would fill in the blank. So on the SO I would say, like, select the answer that would fill in the blank. So it's shifted up, right? It's positive 4, so we went up 4. Then they're going to ask us in terms of steeper or less steep. So let's compare. The graph g of x is either steeper or less steep than the graph of f of x. When we take a look here, here my slope is 1, here my slope is 1/2. When I have a smaller value, it goes less steep or flatter. When I have a bigger value, it gets steeper. So since 1/2 is smaller, a g of x slope is smaller, that means that it gets less steep. The graph is less steep. Now go ahead and get out your calculators. Let's just refresh your memory of how to graph this on the calculator. Because you can always graph it too, just to double check that it did indeed go up 4 and that it is less steep. So the nice thing with the graphing calculator is that you can actually graph more than one graph at the same time. Alright, so I'm going to go and clear this out. Remember, it's how we get to this screen here. What do we have to hit? Good, it's a bunch of y equals, so you hit y equals. So you're probably on like a home screen, go and hit y equals. So my original parent graph is just y equals x. They already have y equals, so I'm going to type x. And then to see what this graph looks like, see this button called graph. All I have to do is hit that. So that's my original parent graph. Now, depending on who's used the calculator before you, this screen might not look the same as mine. It might be zoomed out or zoomed in. You might not even see the x and y axis here. So if it looks funky to you, you can always hit zoom, like they might have zoomed in differently. And zoom 6 is zoom standard or Z standard. That's our standard way of looking at things. If you just hit 6, it'll make it come back to this. So if yours looks funky, just hit zoom 6 and it'll bring you back to this. Okay, so that's my original parent graph. So now let's take a look at how that compares to the graph that they're asking about. 1/2 x plus 4. So let's go back to our y equals. And I want 1/2 x plus 4. You can either do parentheses or we can do a fraction using alpha y equals. Gets us that nice fraction. Again, that was alpha y equals. And then enter. So I can have 1/2 x plus 4. Now what we said is that it went up 4 and that it's less steep. So if I go and hit graph, it'll graph that new one, and we should see that it went up, and it definitely went up. And if we compare, notice it's a little flatter. So here was our original, and then now it's a little flatter, so less. If you want to compare the individual things, you could even say that you just want to know if it's shifted. You can take off this the slope and just say x plus 4. If you want to just look at the steep, you can take off your y-intercept and just look at your slopes. But you can just graph it that way. So you can use that to double check. But again, we can just look at our equation to know. Okay. Do you have any questions with that part? All right. Just going to take a look at our last column here. So this is another type of problem the SO might ask in lesson test. At each point on the coordinate plane, this is our coordinate plane, a line will extend through the 2 points. So on the SOL, you use your cursor and plot the point, and the line automatically shows up. We have to actually draw it because we're not on the SOL right now. So here's our original graph. They went ahead and graphed that parent function. Right, this is my parent function. And again, this is just the same thing as saying y equals x. That's just it. Okay, so now they're describing another graph to us. They say it shifted down 4 units, and it is twice as steep. So if it shifts down 4, that means that I want to say minus 4 on the end. That means my y-intercept is going to be negative 4. And if it's twice as steep, that means that I want my slope to be twice what it currently is. What is my slope up here for my original paragraph? 1. What is 2 times 1? 2. So I want to do twice that, so 2 times 1, which is just 2. So my slope is going to be 2 over 1. So all they did is they just told you in words, what is my y-intercept? Negative 4. What is my slope? 2 twice, so 2 times the slope, so 2 over 4. So all we have to do is plot those points. So again, let's plot our y-intercept to negative 4. 1, 2, 3, 4. And then our slope is up 2 over 1. Up 2 over 1. Now, they only ask for 2 points. I'm going to go just graph a few more just to make the line a little bit easier to draw. Down 2 over 1, down 2 over 1. Naomi, just go ahead and connect. So these are kind of examples of how they ask about transformations. It's basically using more words. And again, vertical shift, that's our change in our y-intercept. And steep, less steep, that's going to be talking about our slope. And if they talk about reflection, that means that we have that negative slope. Do you have questions on that? So we're going to do some practice with this. I'm going to just take a minute while I get things situated for that, just to kind of look through your foldable. And I'm going to bring it back to that first page for those that came in a little late. Alright, so we're just going to do a little bit of practice with this, just kind of together going through this PowerPoint. And you'll, again, notice, so today we didn't have our mini quiz, so next class we do have a mini quiz over what we did today, our transformations, and last class's stuff, which is just graphing. So we did more practice with the graphing today. And so what we'll do is we'll probably do that part of the in class and then do some more practice with transformations. And then we'll do a mini quiz at the end. And we're getting toward the end of our unit. We have next class, and then a review, and then our test. Okay, so then in this PowerPoint, what we have, it says, find one way the graph is different from the parent function. And so it's going to show you can kind of see it's going to show 2 graphs to you, and then we're just going to describe one way that it's different from the parent function. Okay, so again, here's my original parent function here in red. So what is one change that happened to get to the purple? What's one change that occurred? So what did you say? Yeah, we swapped it. What do we call it when we swap it or flip it? Reflection. Good, reflection. And so we notice our slope is negative here. Good. Okay, how about there? Here's my original parent. What did the purple do? Yeah, it went up. How much did it go up? Up 5. Good. We can see my y-intercept was at 0. Now it's up 5, so we call that a vertical shift. Sometimes they'll say up 5, sometimes they say vertical shift up 5. So we have that there. All right. Next we've got this guy. So here's my original. Notice y-intercept stayed the same here, but what did change? It's a dilation, which means their slope changed. Would we say that purple is more steep or less steep? Less steep, good. I'd rather run up this hill than run up the red hill. Is anyone doing track right now? Like indoor track? Have they made you run hills yet?
Yeah.
So this should relate to you. You know, uphill, downhill. This is the real type of hill that I like to run on. This guy. Going down. Okay, what do you think? Sledding? Ooh, guys, maybe we'll get snow one of these days. Okay, so here, notice our y-intercept is different. So what is the change that occurred for this? How could I describe this change? It's going down. How much has it gone down? Yeah, so this is a vertical shift down 7. Our y-intercept would be -7. Good. All right, this one I want you to discuss with someone nearby you. If your shoulder partner's not here, you can just talk with someone close to you. But here's my original parent. Notice it's still a y-intercept of 0. But what has happened? Describe that graph to your shoulder partner. I've heard 2 people talk. Everyone should be talking to their shoulder partner. Say, hello, shoulder partner. My name is so-and-so, and I think that this graph All right, what do we think? Dilation. And that means what? Good, the slope increase, it got steeper. That's the kind of hill we want to avoid. In college, there was one time we did a workout where we ran uphill for 3 miles. It was on a road that just went up for 3 miles. The guys did 5 miles. It was a lot of fun. Fun indeed. You say what class is that? Oh, it was for cross country. It was for a sport. But there was a running class that they do a lot of hills. You didn't have to take it. Those were just the crazy people that took that. Okay, so now we're going to talk about 2 ways the graph is different. Because all of these, only one thing changed. But we can make it steeper, and I could take this purple line and move it up, right? So that's what we're going to take a look at next. Okay, so there's 2 things that have happened here. Who can name one of these things? Reflection, I like that. All right, it went the other way, so we've got to go the other way. What else has happened? Vertical shift. Good. A vertical shift is that it went down, what is it, 4? Is it down 4? Yeah, down 4. Good. All right. All right, what has happened to this guy? Ooh, I can use these note cards here. I love the note cards. You guys remember writing these note cards at the beginning of the year? Nope, this is where you told me fun facts about yourself. Jonathan, you cheater. You wrote nothing about yourself. You sneaky sneak. Now I know your birthday, though. Hey, it's coming up. A couple months. Or no, like a month and a half. Okay. We'll just let this one be a freebie. Who can tell me one thing that has happened to this graph? Raise your hand. Who can tell me one thing that's happened to this graph? Andrew?
The line got shorter.
Good, the line got shorter. But remember, our lines do continue on for forever. So what else can we say about it? You're correct. Yeah. There's something that happened to it that made it so less shows up on our graph. It is less steep. Good, it's less steep. Right? And then, Sam, what else? Vertical shift. Good, vertical shift up 8. All right. Our next one. Let's see. Golda, I have you up first in my note card. Golda and Jonathan. Golda, what is one thing you can tell me about my purple graph? It got steeper. Good. Jonathan, that leaves you with the other thing. What else happened to it? I'll give you a hint. Y-intercept? Y-intercept. What happened? My y-intercept was here and went shoo. What does shoo mean? Translate shoo for me. Don't you wish the SOL did that? Where it's like you went to the question and then you hear like shoo. What does that do? If it was here and then it went shoo, down here, what does that mean it did? Ben, you want to help him out?
It went down.
Good, it went down. It shifted down. This one's kind of hard to see. It shifted down 3. Does that make sense, Jonathan? So my y-intercept was here, and we went shoo, down 3. Good. So now you guys know what shoo means. There's actually an audio version of the SOL, but I don't think they have sound effects for it. Okay. Next up, I've got Catherine. You're up, and Eric's not here. Bradley. Catherine and Bradley. All right. So here's my original. Here's my parent. Catherine, what's one thing that has happened? Good, it went the opposite way. So it reflected. Good. And Bradley, what's another thing? So I'm going to give you a hint. Our y-intercept stayed the same, so it's not that it shifted. But if I were to flip this guy around, it'd be something like this. So how can you describe the slope to us? Is it more steep, less steep? Very good. No, that's right. More steep. So it's more steep. Good. I love reading these. Okay. Next up, we've got... All right, so Kimberly and Emma. All right. Kimberly, what's one thing that happened from red to purple?
The purple one is less steep.
Good. Our purple one is less steep. So originally red was like this, now down like that. Emma, what's another thing that's happened? Good, it went up 6. Vertical shift up 6. Alright. So next up we have find the ways the graph is different from the parent function. There could be 1, 2, or 3 different ways. Oh my goodness, does it ever end? There's a lot that we can do to it. So remember, there's 3 things we can have. A shift up or down, a reflection, and more steep or less steep. So those are the 3 things we're looking for. All right. Anthony's not here. I like his fact that he told me. All right, so next up we've got Mena and Patricia and Joanna. Mena, Patricia, and Joanna. So we'll start off with Mena. Mena, what's one thing that happened from red to purple?
It went down 5.
Awesome, good. It went down 5. Good. All right, so we have it went down 5. Patricia, another thing that happened? Good, yeah. So it's more flatter. It's less steep. Very good. Joanna, can you figure out the left? Yeah, good. It reflected. Very good. It's going the other way now. Is my calculator okay? All right, good. All right, next up we have this one. And let's see who we've got. We've got Andrew, Michaela, and Alan. Oh, Alan, sorry, you have to wait to the next one. Andrew and Michaela. Okay, so from red to purple, Andrew, what's one thing that happened?
The purple one got
Very good. It got steeper. Yeah. And Michaela, what's the other thing? Good. It went up 2. Awesome. Okay. We'll do one more here. So we've got Alan. Oh, no, we need to do more than one more. We've got more people. Okay, we'll do 2 more. Alan and Gabby. Okay. So my original, here's my purple. Alan, you get to go first. What's one thing that's happened? Down 4, and Gabby's like, no, he took the down 4. Good. Gabby, can you tell me what else happened? Good. Good. It got more steep. Very good. Awesome. Okay. How many more do we need here? Roll. Golda, did I start off with you?
Yeah.
Okay. Our next one. All right, we've got red, purple, and I'm gonna go with 2 people for this one, Sam and Angela. Sam, tell me one thing that happened to my purple here. Good, it reflected, right? It's going, instead of here, it's going the other way. Good. And Angela? Good, it got steeper. It's definitely more steep. All right. Next up, we have this guy, and Katya, and Rodrigo. I think we just need 2 for this one. Katya, can you describe one thing that's happened to the purple for us? Good. It went up 3. Good. All right, Rodrigo, can you guess the other thing? Yeah. So we have that it ends up, it's a dilation, it ends up going, is this one flatter? A little flatter, less steep? Good. All right. And then I think we have our last one here. So Alessandro, I know you just came back, but what we're doing here is we're just describing what happened to get from the red graph to the purple graph. So we've got, it could reflect, it could flip around, we could have it shifts up or down, and we can have more steep or less steep. So next up we have Alejandra and Alessandro. Alejandra, can you tell me one thing? Good, it reflected, it went the other way. Good. Alessandro, what else do you think happened here? If my original red graph started down here, and now my purple graph starts up there, how could we describe that? So reflection, you're correct, it did reflect because it's going the other way, right? What do we call that? How would you describe going from here to there? What would you say in your words? Did we go up, down, left, right? Yeah, good. We went up. We went up 8, so we'd have also, very good, Alessandro, a vertical shift up 8. Okay, I think there's some people that we didn't get because we added to my class list. We're going to go Angelica, Kelly. Who else was? Your name wasn't in here? I see. Oh. I had you right here. How did I miss that? All right, next up is Isatu. And Kelly. And Angelica. All right, Isatu, you're first. What's one thing that happened? Good, it switched. We reflected. Good. Kelly, what's another thing that happened? Good, it went down 6. And Angelica? I'll give you a hint. It has to do with their slope. I feel like these ones are harder to see when they're going the other way. So my original looks like this. What did the purple do? More steep or less steep? Good, more steep. Good. Who else am I missing? Marjorie, I didn't forget about you. Aurelio, I feel like you didn't speak yet either. Omar, did I get you?
No.
Omar, how did I miss out on you? All right, my next one.
Oh.
All right, we're going to go with Omar, Aurelio, and then Marjorie, I'll get you on the next one. All right, Omar, tell me one thing that's happened. Oh, wait. I guess we just need Omar. Omar, what's one thing that happened? Good, it's less steep. That's actually the only thing that happened. Okay, let's take a look at this one. Aurelio, I'm making you go first, sir. I can see you back there. What is one thing that happened from my red graph to my purple graph? Good, it went up. We went all the way up here to 7. Marjorie, can you tell me the other thing that happened? If it's going this way, now it's going this way. Remember what that's called? That's the sound effect for that one. That's what you would hear. That's what I hear when I see it. What do we call that when we... I almost said it. What do we call that when it goes the other way? How would you describe it? In your own words. So don't have to be mathy words. Let's call on Sajib to help you out, because Sajib, I think I don't have your note card either. You thought you were going to get it by without saying anything. So on G pilots, how do we describe that? It's going this way, and then now it's going this way. Good, reflection, good. Reflection, good. Okay, I think I made everyone speak to me. Is there anyone that I missed silently sitting there? Very good, you guys survived the note cards. And now I know I need to get some of you guys to write out your note cards. Okay, good, so that's just some practice. This one here, we have it's less steep. Look at how less steep that is. It's like a nice little incline there. Here we've got shifted up and more steep. Reflection, that's the only thing actually that happened there. Down one, less steep. Down two, more steep, and a reflection. Man, how many? Oh, here's the last one. Okay. And then up 5, less steep. So those are the 3 kind of main things that they're going to be talking about. Good. Questions with that? Sorry, I made you get a calculator. I really didn't use it much. I already have this and that. Okay, yes. June 13th, 14th. Whatever the last day is.
What the hell is that?
June 13th, 14th, 12th? No, it's about the same. Oh no, I wish. It was definitely, yeah.
I don't know, I like them. Oh, no, I feel bad.
You what?
I broke my leg after squatting up the bed.
How did you manage that?
Jaywalk.
Did you get hit by that car?
No, I didn't get by a car. I crossed the street and then when my foot hit down, my leg gave out and slammed my knee.
Yeah, you sound like awful.
I hit my head. That's an older one.
Good thing Scott is over at that. Right, coming to use your homework worksheet 14. So again, you'll see on the graphs they have drawn a nice dotted line, the original parent, and then they have drawn solid the new graph. That's what it is, right? Go ahead and return your calculators. Erase your name from the board.